All right, in this section, we're going to talk about hypothesis test. This corresponds to section 9.1 through 9.34. Our goal is to test the truthfulness of the claim, I'm going to underline claim, about the population parameter. So this is like extension of idea of confidence interval. Confidence interval, we'll try to estimate population parameter, for example, population mean or population proportion. So here we're kind of doing the same thing, but we're now testing a particular claim about a population parameter. So for example, somebody says, yeah, about 3% of Angelinos have coronavirus. Angelino, corona. Again, how do I know that's true, right? So again, we'll never be able to tell if that's actually an accurate statement, because again, we don't have complete information about the population. So what we try to do is we'll try to get a sample and try to inference or make an educated guess that if we like the statement or we don't like the statement, right? So we can never, typo there, definitely say whether a claim about the population parameter is true or not. What we can do is collect sample data, and determine if the sample data suggests that we should support the claim or reject the claim. Support the claim basically means that we think the claim is true. And reject the claim basically means that we think the claim is false, right? So I'm going to see the statement. It's like I'm going to kind of decide, do you think this is a true statement or do you think it's a false statement, right? So in order to test this, we first collect a sample data. In fact, we need a random sample, a simple random sample, and throughout the section, we're going to assume that all our samples are simple random sample. All right, let's look at the next part. Based on the sample data, we're going to use a formal procedure called hypothesis testing and draw a conclusion about the mean. So this one is this section, everything is very structured. We're going to follow this procedure. It's pretty set. So we'll talk about like the first part of this procedure called hypothesis testing. So we have the following. We're going to make one of those following conclusions. The sample data support the claim. Basically, we think the claim is true. The sample data rejects the claim. Basically, we think the claim is false. But there's this third thing. The sample data does not support or reject the claim. Basically, it means we can't really conclude anything. And sometimes in the article newspaper, you'll see that study is inconclusive. It just means it doesn't support the claim nor reject the claim. Okay, and our first step of hypothesis testing is to set up a null hypothesis, and alternative hypothesis. I will talk about like what those two things mean. Let's erase this part here. Okay, so the claim will correspond to either a null or alternative hypothesis. Depends on how it's phrased. So our first step is I'm going to read a claim and then decide if the claim is null or alternative. A claim will either contain a statement involving equality, which is like the equal sign, or strict inequality, which is the less than or bigger than or not equal to. Equality also includes less than equal to, bigger than equal to. So anything that has like the equal sign, that line, extra line. So statement of equality contains a word that translates to the symbol less than equal to, more than equal to, or just strictly equal to. And statement of strict inequality. Inequality means they're not equal, so one's smaller than the other one, vice versa, or not equal. So every claim will have one of these symbols. So if you see one of those symbols, then your claim is going to be null hypothesis. If you see one of these symbols, then your claim is going to be alternative hypothesis. Alternative hypothesis. All right, let's look at the next question, number 1. Let's look at the first statement. The mean height of all stat professor is 68 inches. Well, it says is equal to something. So they're saying is equal to, right? So I'm looking at that. So it has to be equality statement. the second statement says proportion of left-handed math professor is more than. Okay, I'm gonna here like more than, so that means it has to be bigger than 15%. So that'll be streak inequality more than. On average, students spend at least 5 hours. Oh, there's this at least again. Again, we're thinking about in order to buy alcohol, you have to be at least 21. What does that mean? You have to be either 21 or higher. So 21 is included, or it could be higher. So at least 5 means bigger than or equal to 5, right? It could be 5 hours, it could be 6 hours. So it'd be equality statement because at least 5 means x is bigger than equal to 5. It could be equal to 5. So there's the equal sign. The last statement, 10 years ago, the proportion of full-time student was 60%. The current proportion is different than 10 years ago. Well, it says different. It just means it's not equal to, right? Not equal to. So that means it's a strict inequality where it's not equal to. So statement, the claim is going to come in like normal language, and we're going to translate that into one of those 6 inequality or equality, and that'll help you decide if it's going to be null hypothesis or alternative hypothesis. So having said that, if the claim is a statement containing equality, then claim corresponds to the null hypothesis. Null hypothesis denoted by H0. Sometimes I'm going to call it as H0, N-A-U-G-H-T. Not just means 0 or circle. So you'll sometimes I'll say it's H0, sometimes I'll say it's H0 is the null hypothesis. Those 3 things are the same thing, different names. Second part, if the claim is a statement containing streak inequality, again I'll underline streak, whereas then the claim corresponds to the alternative hypothesis denoted by HA. So what's the difference between these two? Conceptually, the null hypothesis is what we're assuming to be true, and the alternative hypothesis is opposite. So here, alternative just means opposite. So if you look at it in a little slightly more detailed way, if I look at equal, what's the opposite of equal to? Well, it's not equal to, right? So that's that. So let's say we have less than or equal to. Again, what's the opposite of less than or equal to? Will be bigger than something, right? So that'll be this symbol. And third one is what's the opposite of bigger than or equal to? Again, opposite of bigger than something, that means smaller than something, right? So it'd be smaller than. And as I mentioned before, our claim will have one of the 6 symbols in it, and depends on what the symbol is, we can pick H0, and HA accordingly. All right, let's look at number 4. I'm gonna do 1. I'm gonna have you guys finish the rest of number 4. So look at the first one. It says for each of the following claims, write down the H0, Hn, identify which corresponds to the original claim. Okay. It says the mean height of all professor is 68 inches. First of all, it says mean height. So, okay, the average height of all professors. Okay, sounds like it's population. Population mean, the symbol is mu. So I'll use the symbol mu. Says it is equal to or is 68 inches. I can translate that as is equal to 68 inches. So it'll be like this. So that's the claim. Again, I'm looking at the chart here. I have equal sign. That means it's got to be H0. So I'm going to come here. All right, H0 is basically mu is equal to 68. What does that mean? That means HA, which is alternative hypothesis, which is the opposite of H0. So what's the opposite of mu is equal to 68? Mu is not equal to 68, right? So there's my H0, there's my HA, and this happened to be my original claim. Sometimes I'm going to write it as OC. Okay, I'm going to have you pause and finish the rest of number 4. Okay, now let's look at number 5. So far we talked about how to set up, how to start our hypothesis test. And now let's look at the next step. The next part of the hypothesis test procedure depends on the rare event rule. which states, if under a given assumption, the probability of a particular observed event is exceptionally small, we conclude that the assumption is probably not correct. Wow, okay, there's a lot going on here. Let's look at the part where it says probability of a particular observed event is exceptionally small. Doesn't that sound like basically it's like an unusual event? Unusual. Because it's an event that has small probability. So I'm going to refer back to this like a lot in the future. I want to look at something is unusual or not. So unusual means we have very small probability. It's like same as an outlier concept, right? And also if you look at the last part, it says assumption is probably not correct. Basically it means, yeah, it's false, right? And we're going to say we're going to reject this. We're going to hear this again in the future, but it's like, well, yeah, it's not correct means, yeah, I think it's false. Or I'm going to say I reject that, right? It's my little side note. So each piece of this statement corresponds to different part of our procedure. So given assumption corresponds to the null hypothesis, because that's what we assume to be true. That's why we need to kind of set up the null hypothesis. A particular observed event. Basically, observed event means it's a sample, because that's what we survey and what we observed, right? And the p-value, the probability of particular, so probability. Again, since we have to kind of look at the probability to see if something is unusual, so probability of a particular observed event occurring is called the p-value. So basically what's our strategy is going to be, we're going to basically reject things that are unusual, things that are unusual. For example, I have a friend who bought a lotto ticket and he's like, this is going to be a jackpot. And in my head, I'm like, I don't think that's going to happen because, well, probability of winning a jackpot is very, very, very low. So like, well, how do you know that this ticket is going to be a jackpot? So what I'm thinking is, because this winning a jackpot has such a low probability, it's such an unusual event. So I'm just going to say, no, it's not going to happen, meaning I'm rejecting the statement. And we're going to kind of do the same thing for our hypothesis test. Our next question is going to be, how do I decide if something is unusual or not? Or how do I decide something has a small probability or not? Before, we kind of used 5% as like a guide. Anything less than 5%, we say it was a small probability. Here, we're going to kind of make it a little bit more precise. So we will decide ahead of time what we consider exceptionally small will be. And this number will be called significance level. So it doesn't have to be 5% all the time. It is denoted with the Greek symbol alpha. If it is not specified, we'll assume it is 0.05, which is basically 5%. So basically what it says is usually anything less than 5%, we're going to say it's unusual. But from now on, each question will specify like, oh, maybe 3%. Anything less than 3% is unusual. So they'll give you this number. So this number alpha, which is significance level, will be given. If it's not given, we'll just take 5% as a default. In number 6, it kind of gives you a theoretical background, and you'll notice that it's very similar to confidence interval. So if the null hypothesis H0 is about P, which is population proportion, then we're going to basically what we're going to look at is we're going to look at the sample proportion, which is going to be normally distributed with the mean is NP, and standard deviation is PQ over N. And when we're talking about sample mean, population mean mu with sigma known, then we're looking at the sample mean, and it's going to be also normal with the mean of mu and sigma over radical. And again, this comes from confidence interval, which comes from central limit theorem. Here, the first two, we have normal distribution. So basically what it means is we're using z-score, right? Here we're using z-score. The third one, hypothesis test about population mean, mu, with sigma unknowns. So again, this is different than the previous case where sigma is known. We'll be using t distribution instead of the normal. So this is t-score, right? One more information we need to know to find the p-value is the tails. So when we have a left tail situation, then HA, the alternative hypothesis, has this symbol. If you have a right tail situation, then HA has this symbol. When you have two tail situation, then your alternative hypothesis has a not equal to a symbol. So this will be needed when we try to input our information into a calculator. All right, let's look at number 8. How to use your calculator to find the p-value given HA and a sample data for a proportion test. Remember, for proportion, we were using normal distribution. So what we're going to do is we're going to go to, on your calculator, we're going to go to stat, then we'll go to tests, then we'll look for testing on proportions. So it's called 1 proportion z test. So that's option 5, 1 proportion z test. Again, PROP for proportion, z test because we're using normal distribution. For a mean test with sigma known, again, same thing. If you look at what we had before, when sigma is known, we'll still use normal distribution. So just keep that in mind. So on your calculator, I'll go to stat, I'll go to tests, and if you look at the first one, option 1 is the z test. Okay, so I'll pick that. And part C, for a mean test when sigma is not known. Again, when sigma is not known, we used a t distribution instead of z distribution. So we'll kind of do the same thing here, or on your calculator, I go to stat, we'll go to tests, and right under z test, there's a t test, option 2, t test. All right, let's look at number 9. I'll do part A, and I'm going to have you finish the rest of it. It says, for each of the following examples, calculate the p-value, indicate the calculator function you use, and sketch the graph. Okay, fine. So let's look at the first one, part A. HA mu is less than 98.6. I noticed they didn't give me H naught. Well, if I were to write that out, I know H naught and HA are opposite of each other, so HA has mu is less than, so it must be mu is bigger than or equal to 98.6. I'm just going to put it right there because it was not given to me. X bar, this is my sample mean. You notice there's a lot of information, so I want to kind of label it so I don't get confused. I notice it says S is equal to 1.9. There's S and there's a sigma. Sigma is for population standard deviation. S is for sample standard deviation. So I notice there's a sample standard deviation. Okay. N is the sample size. Sigma is 2. They also give me population standard deviation. Again, in real life, probably we don't know population standard deviation. We only know sample. But in this particular case, they're giving me population standard deviation. So I'll use that. Again, I'm looking at the previous number 6. We're doing hypothesis test on mean where sigma is known. So we're using z-score, so that's normal. That means here I'm going to use z-test function key. So I'm going to keep that in mind. So what I'll do is I'll go stat, test, and then I'll do z-test. Because sigma is given, even though S is given, sigma is also given. So if that's the case, I'll use the population standard deviation. Right, so when you go there, calculator, we're going to ask you to input mu naught sigma x bar n, and then mu, and then color, and then calculate. So here we have a bunch of statistics. So I'm going to choose statistics option. Here, let me just circle this so you know these are calculator function keys. Mu naught, what is that supposed to mean? It just means copy the number mu from your h naught, see that's 0, that's naught, right? So h naught mu is equal to or bigger than equal to 98.6. So that's the number I'm going to input. Sigma is 2. X bar is sample mean 98.1. N is the sample size 50. And the last part, I see a bunch of inequalities. Here, I copy it from HA. This is what we were talking about previously. So if I'm looking at HA is less than symbol, so I'll pick that symbol. And once you hit calculate, you'll notice it'll give you a bunch of answers. One of the answers you get is P is equal to 0.0385. So I'm going to round to 0.039. So that's the answer I get. If you kind of go back there again, instead of doing calculate function, if you did the draw function, it gives you graph of what we just calculated. So in terms of graph, again, it's a z-score, so we have normal distribution. Your tail is to the left because you have a less than symbol, and your p-value is 0.039 because that means the area we calculated was 0.039. Basically, your sample lies right here. So by looking at it, I can kind of see the sample is kind of unusual because it's less than 5%. So we'll talk about that in more detail. But for now, I'm going to have you finish number 9. And this concludes part 1.